Hi, pre-algebra students, here are your notes for section 5.5 on special cases for systems of equations. So we're going to start today with some review of systems of equations and look at graphically how we know if it's a one solution, no solution, or infinitely many solutions. So if you want to pause your video and go ahead and try this on your own, you can, and then you can restart the video. But I'm going to go ahead and just draw some examples here. So let's take a look at the first one. For a one solution, remember that your two lines have to intersect in order to form a distinct point of intersection. So I'll draw an example, and this is a little bit open-ended. It doesn't have to look exactly like mine, but you just want two lines that intersect. Let me grab a second one here. Okay, so I drew one line with a positive slope and one with a negative slope. You can draw one horizontal line and one vertical line. And of course, normally we're looking for a clear point of intersection, but since we're not actually trying to find a solution, I didn't worry about doing that this time. So in the second graph, we're looking for an example of a no solution. And remember, graphs that have no solution is going to give you a set of parallel lines. So again, in any direction. So I gave my graph two lines with a positive slope. It can be two lines with a negative slope. It can be two horizontal lines, two vertical lines. And then lastly, we have a graph with infinitely many solutions. And remember, this is basically the same equation. So a lot of times it's going to look just like one line, but really what it is two lines that coincide. So it's that one line that is directly on top of another, kind of just like that. All right, so let's go ahead and look at this next section. So remember, again, earlier in this unit, I believe it was in sections like 5.0 to 5.2, this was on your first quiz. How do we know if an equation has one solution, no solution, or infinitely many just by looking at the slope and the y-intercept? So originally I gave you these systems of equations and said rewrite each set in slope-intercept form to determine the number of solutions. But to be completely honest, I would not use that method if the equations were not already in slope-intercept form. So I'm not going to use these equations. I'm going to go to a different source. So we're going to pull up, and you should have this in your OneNote as well, this worksheet called 5.5 Practice Number 1, and we're going to take a look at this. Okay, so most of these are already in slope-intercept form. You can see I've got to do a very slight tweak to the second equation in number 1. I just need to add 3x to both sides. So if I do that, remember I can't combine the 3x and the 5 because they're not like terms. So if I rewrite this equation, it's going to say y equals 3x plus 5. And now if you look at the first equation and the second equation, you can see very clearly that they have the same slope and the same y-intercept. Therefore, this set has infinitely many solutions. It's going to be that graph of the same line. Okay, and number 2, both of these equations are already in slope-intercept form, so I'm just going to compare the slope and the y-intercept. And in this one, I can see that the slopes are the same, but the y-intercepts are different. And when this happens, remember, this is going to give you a no solution. It's going to be the graph of two lines that are parallel. In example number 3, if I look at my two slopes, let's fix that real quick. Let's see. There we go. I can see that my slopes are different. And as soon as I see that the slopes are different, I know automatically that this is going to be a system of equations with one solution. Those two lines are going to eventually intersect and give me one distinct point. Number 4, again, both equations are in slope-intercept form, so I can see that these have the same slope and different y-intercept. So this is going to give me a no solution. And again, remember -9 and +9 are not the same number. You have to pay attention to the signs that precede the numbers there. Okay, so these are not exactly the same equation. In number 5, both equations are in slope-intercept form, and I can see immediately that these have different slopes. So therefore, there's going to be one solution. And lastly, for number 6, again, I have to do just a very slight tweak to this one. I got to add 8x to both sides. So this equation is going to become y equals 8x minus 2. And again, if you look at the first equation and the second equation, you can see that they have the same slope and the same y-intercept. Therefore, this is going to be an infinitely many solutions. Okay, you're graphing the exact same line. All right, so if you need to pause the video and go back and look at any of those, please do. We're going to keep moving on. So I'm going to go back to the other set of notes that we were looking at. So if you go back to the notes for 5.5, we're going to keep moving on, okay? So this section is all about learning how to solve them algebraically and look at the results to see if it's a one solution, no solution, or infinitely many. So the first thing that we're going to do is just talk about when it's appropriate to use each method. So now that we've learned how to solve using substitution and elimination, when do I use each of those? So substitution is a method we use when both equations are in slope-intercept form. And of course, this is when we're not graphing them. So maybe we don't have graph paper handy and we just want to solve them algebraically. Or when one variable is isolated. Okay, so that means one equation is an x equals or a y equals equation. Elimination is a method we use to solve when both equations are in standard form. And remember, that's our ax plus by equals c when both variables are on the same side of the equation. So let's go ahead and try this. We're going to look at these 3 examples, and you'll notice the first 2 are in slope-intercept form. So again, I could solve this by graphing because those 2 equations would be super easy to graph. But let's say I don't have graph paper, so I just want to solve them really quickly by using algebraic method. So if I look at my 2 slopes, I can see by comparing them that one has a positive slope and one has a negative slope. So I know automatically that it's going to be a one solution, okay? So I need to solve this equation and find the solution. So remember, I'm going to take, when both equations are in slope-intercept form, I take one of the values of y. So I'm going to take the y equals x plus 3, and I'm going to substitute this expression in place of y in the second equation. So this is an equation that I definitely want to use substitution on. I should have talked about that first. Okay, so we're going to substitute the x plus 3 in place of the y in the second equation, and then just bring down the negative x plus 5 on the other side. Okay, so since this is an equation with variables on both sides, I want to use inverse operations to isolate the variable. So I'm going to get all of my x's on one side and all of my numbers on the other. So I'm going to start by adding x to both sides. X plus x is 2x. And then everything else drops down. So plus 3 equals 5. Okay, now we're just solving a 2-step equation. So my next step would be to subtract the constant from both sides so that I can isolate that variable. So 2x equals 2. This is pretty easy to solve. So therefore, x equals 1. Okay, so now that I have a solution for x, don't forget I need to go back and solve for y. And remember, I've told you before that the easiest way to solve for y is to take the value of the first variable and you want to plug it back in up here in the blob. Okay, so go back to your blob. So if x equals 1, then y is equal to 1 plus 3, which is 4. Okay, so I now know the value of x and I know the value of y, and I'm going to write my solution as an ordered pair. X is 1, y is 4. So my solution is 1, 4, And that was a one solution equation. Not that you need to clearly state that, but it's just helpful to know. All right, so don't hesitate to pause the video if you need more time to copy down that work. I'm going to go ahead and keep moving to number 2. Okay, so in number 2, I can see that the first equation is in slope-intercept form. The second equation is in standard form. So again, this is a good example of a system that I would use substitution to solve, because I have one variable that is isolated. So right here in the first equation, I'm going to take this value of y, and I'm going to substitute it in place of y in the second equation. So let's go ahead and do that substitution first. So everything drops down. Remember, I need parentheses around the expression that I'm substituting. So the, whoops, that's not a 2. Fix that. That is a 5x minus 2. And then equals 4. Okay, so I took the expression 5x minus 2 and substituted right here. Whoops, let me grab my pointer here. Okay, substituted that right here in place of y in the second equation. All right, now remember from this point, I used those, remember the steps we talked about, don't call me after midnight, to solve as equation with multiple steps. Sorry. So I'm going to go ahead and distribute first. So my 10x drops down. And then remember, I'm distributing a negative 2 here. So negative 2 times 5x is negative 10x. And then negative 2 times negative 2 is positive 4. Watch your signs when you are distributing. Okay, so remember my next step is to combine my like terms, which are right here. So 10x minus 10x is just 0. So that variable term drops out, and I have the solution 4 equals 4. So down there I said, is there a solution? What do you notice about this? So notice that your variable term drops out, and you end up with the same number on both sides. And this creates a true statement, which means that there are infinitely many solutions. Okay, which we can abbreviate IMS. All right, let's look at the last example. Notice in these two equations, they're both in standard form. So this time I'm going to use elimination to solve. Okay, so remember I'm looking for a variable with a common coefficient, and actually both of them have the same coefficient. So remember, in that case, I can choose to eliminate x, or I can choose to eliminate y. Since x comes first, that's the one that I'm going to focus on. And notice they have the same sign. So remember, same sign means subtract. So always show your subtraction sign. And then remember, I've told you when you subtract, you want to add the opposite. So we're going to add the opposite of everything in the second row. So the 2 becomes negative, the 4 becomes positive, and the 10 becomes negative. And then we're adding, so we're really just combining like terms. So what you'll notice here is when you add your variables, 2x plus negative 2x cancels. Negative 4y and a positive 4y cancels. So really you end up with just 0 on this side, and then 20 plus negative 10 is 10. So again, is there a solution? No. What do you notice? Okay, so hopefully you're noticing that your variable term dropped out, and you ended up with 2 numbers on either side that create a false statement. And when this happens, this means there is no solution to this system of equations. So you can abbreviate that NS for no solution. All right, so please take a few minutes and just look that over and study it. So those are the 3 kind of possible solutions we can have: a one solution, a no solution, or an infinitely many solutions. And then down here, I gave you an example of that in a graphic organizer. The first one, this is our one solution, and this is just a reminder that 0 is a solution. So I think a lot of times you guys think that if the answer is x equals 0, that it means no solution. But just if this were the situation and one of the variables would say x equals 0, then that just is a reminder that you need to go back and plug that in and solve for the second variable. No solution, again, is when your variables cancel out and it creates a false statement. And then remember, on this last one, we don't typically say all real numbers. We say infinitely many solutions. It means the same thing. And of course, either would be fine. Okay, so we were challenging you here if you want to go back and look at the puzzle. This was just kind of a fun challenge. So if you notice, we're looking for, this is open-ended, and it says, fill in the boxes to give the number of solutions. So how do you find an equation that has no solution, one solution, or infinitely many? So if you notice, the equation on the left is exactly the same in all three examples. So the first thing I would probably do is simplify this by combining my like terms. So 8x minus 3x is 5x, minus another x at the end is 4x. So all of these really just simplify to 4x plus 2. Okay, so we talked about this in class, and we talked about what would it mean in order for an equation to have no solutions. Well, remember we said in order to be a no solution, those lines have to be parallel, so they have to have the same slope. So this has to be a 4, but this can be any number but 2, okay? So it can't be a 2 because they can't be exactly the same equation, but it can be any other number but 2. So it could be like a 6. And then in order to be a 1 solution, remember that the slopes have to be different. So this number just has to be any number but 4. So you can't have a 4 there, okay? So like you could have a 3 there. And then this can be any number because it doesn't matter what the y-intercept is. So it could actually be the same y-intercept, but you would have to have a different slope. And then, of course, in order to be infinitely many solutions, those two equations have to be exactly the same, okay? So this one only has one answer, okay? You can only have 4x plus 2 because they have to be identical. All right, friends, please take some time to study that. I know, I think in your notes also, we put this graphic organizer in there for you as well, so you can go back and study that also. This is a great way to determine the number of solutions by looking at the graphs, by solving it using substitution, or by solving it using elimination, okay?